All right, so this is TEAS geometry, and I'm going to, since this is a recorded only class, I'm going to abbreviate the class a little bit, run through the concepts a bit quicker, and not pause for where I would normally pause to do work while we're live. So I will let you know when you would be pausing and doing the next problem to get the most out of the recorded class. That is what you'll want to do, is still go along with the class just like you would if you were here and we were live and I gave you the pause, but you will pause the video to accomplish that. That will allow me to go a little bit deeper into a little bit of the subject matter than I typically do. So when we think about geometry, we want to think about what the big categories of geometry questions are in terms of what we might actually run into. So we will run into things that ask us about areas and perimeters of rectangles. So those are pretty simple. A lot of that is review for most people. You will be expected to have a formula for any one of these. You will not be given a formula for any of these things. And then what I like to call, and I'll kind of bullet point this underneath, what I like to call backward solving. And every area of math has some type of backward solving idea to it. This particular one, the backward solving, will be areas or perimeters of rectangles. The next area we will explore will be irregular rectangles. So irregular rectangles aren't exactly rectangles and they aren't exactly anything else. So an irregular rectangle will be a little bit trickier to solve because we'll have a couple of extra steps. We will then talk about circles. And as a subset to that, and something I normally don't cover within the live class because I cover it in an additional class later, is the idea of half circles and how the equations work for those, as well as one more concept that I usually don't get to, which is Pythagorean theorem. And that has to do with right triangles. So these are all the concepts that you will encounter if you do take the TEAS and you take the geometry section. The geometry questions that you will get are fairly limited. So in the sense of being prepared, you're kind of preparing in a narrow spectrum, and you're only really going to grab a few questions that are really in this category at max. So these are skills that are good to sort of focus in, push pretty hard, and get good at really quickly. So that you can kind of put more of your time into things like ratios, proportions, percentage applications, and things like that. So it's a little bit smaller segment of the test. So let's look at rectangles and let's review a little bit about rectangles and how rectangles work. Now, as with anything that I teach, I do not typically recommend any type of memorization. If you've been around me very long, you know that. And I say that everywhere. I say don't memorize things everywhere. The same thing is going to apply when we do the math for a rectangle. So I don't recommend memorizing equations. To a small extent, you do have to, but you can save yourself a lot of work by thinking of these, just like I say, everywhere logically, and thinking of what they represent and what the logical equation that would get us to them would be based on what they do in fact represent. So the area is going to be the space inside of a shape. So if I switch to a purple color and I shade the area is the space inside of a shape. No matter what the shape is, the area is always the space inside. So that should be your first thought when you think about area rather than a memorized equation that you're thinking of or dealing with. Your first thought should be it's the space inside. So if you take the room you're sitting in as an example, it's the carpet in the room. If you were to do the perimeter, and I'm going to do blue, the perimeter is the distance around something. So this would be along the pink line. I'm a little off of the line, but that's not because it's different. So the space around, which is usually referred to as the distance around a particular shape, is its perimeter. Now with distance around, you really don't need a formula for this unless you are dealing with a circle. So a circle is the only time you actually need any type of formula, because to get the distance around something, all you ever need to do is add all of the sides. So the perimeter of the room you're in is the walls, or if you prefer to think of an analogy that's a bit closer to where the carpet is, the baseboards. So you could measure each of the 4 baseboards and add them together. And that would be easier than trying to take a tape measure, extend it all the way out, make it really, really long, and try to go around the corners. So that would be a lot less convenient than just measuring each wall and then adding that together. So a perimeter is always obtained by adding together the different sides. So you have a side here, a side here, a side here, and a side here. Now with a rectangle and with a lot of shapes, but not all of them, these 2 are going to be the same, and these 2 are going to be the same. So you're not going to have 4 different sides or 3 different sides. You're going to have 2 and 2, usually thought of as a length and a width. So if you have ever seen them write this equation, because I know you've seen all of these equations somewhere along the line, if you've ever seen them write the equation of a perimeter as 2L plus 2W, and I've even seen that on TEAS materials, that would be complicated to try to memorize that and to try to really just picture that when you're trying to do a perimeter. So I wouldn't recommend something like that, but let's look at the logic behind it. So this is 2 lengths, and this is 2 widths. So if you did, in fact, take the 2 lengths and the 2 widths, and you put them into a combo like that, you would end up with each of the 4 sides, and you would end up adding the 4 sides together. So instead of memorizing a formula like that, or the other formula you might have seen at some point is like length plus length, width plus width, thinking of just adding the sides will always be more efficient than thinking of doing it that way. Now with an area, you kind of need a formula. You can't do it quite as easily as you can do it with the perimeter, and that formula is going to be the length times the width. Something important to note about an area is you couldn't measure an area with a tape measure. So the tape measure was the tool that we talked about with the perimeter. Something that could be measured with a tape measure would be something you would consider one-dimensional. So something that is one-dimensional is something that can be measured in one dimension with one singular tape. Think of what it would look like if you tried to take a tape measure or a yardstick or a ruler, something that's flat and straight, and you tried to measure the carpet in the room you're sitting in. So really try to picture that for a second. Pause the video if you would like to, and think about what that would look like. So the bottom line is you can't do that. You really can't measure the space inside of something with one dimension. What you would need in order to be able to report what the area of a room is you would need to know how many little squares. So if you took 2 rulers and you made them into kind of a square, how many times would you pick up and set down the square, and how many of those do you have? That's really how you would wind up measuring an area. So if I take out this space inside, you would have to measure a length. You'd have to measure a width. So that's why we have 1 of each right here. And you would have to multiply them together because they would create squares with each other like this. So what that leads to is area is a 2-dimensional measurement, and a 2-dimensional measurement needs to be reported in square units or units squared. That is very important because when you go to solve an area question, you'll see your answer, numerically speaking, the answer that you get, let's say it's 200, you'll see 200 twice in your answer list. One of them will say 200 meters or centimeters or whatever they measured it in, and the other would say 200 square meters or 200 meters squared. This is the only one that would be correct if it was an area that you were doing, because it takes 2 different dimensions at the exact same time happening simultaneously in order to be able to measure an area. Now, in the same respect, you also can't use square units or units squared when you're talking about a perimeter. So a perimeter is 1-dimensional, and we don't use 2 dimensions at once. So if you did the same thing and you were using a 200, The area you would want to answer in square meters, and the perimeter you would want to not answer in square meters. So it's very important to make sure you know which dimension you're in and which unit you're going to want as you go to answer the final answer. When we go into a scenario where we solve backwards, we have to be a little extra careful in doing that. So let's look at an example, and for right now, I'm just going to make one up. You have lots of rectangles in your packet. We will hit some of the material out of the packets. Some of it I'll just draw, but it'll all apply to the material that you see in your packets for practice. So as I think about, let's say, a rectangle that has a length of 10 centimeters and a width of 7 centimeters, how would I get the area and the perimeter for this particular rectangle? And that's one of the question types you could get, is they could ask you for one of those properties, generally one at a time, and they will give you either a rectangle or they will describe to you what a rectangle looks like. So pause and do the area and perimeter of this if you are working on this on your own, and apply these sort of logical strategies to the formula. Where we will end up, an area is always going to be length times width, because taking the length times the width will create these little squares that we need. And 10 times 7 will give us 70 centimeters, and it either needs to be centimeters squared or square centimeters. There's no difference between those two expressions, and you'll only have one of those formats available. So the only reason I mention them both is if I only talked about this and you saw this, you might not associate that as being the same thing, but it is. So the area of this particular rectangle is 70 square centimeters, or 70 centimeters squared. The perimeter is going to be derived from adding all of the sides together. So I'm going to fill in the other two sides. You'll never be given 4 sides on a rectangle. You'll always be given 2. And what we want to do is fill in the other 2. We know what they are because the ones across from them will be the same. That is part of the definition of a rectangle. So I'm going to end up with 10 and 10, which makes 20, 7 and 7, which makes 14. So if you put those two things together, you will get 34 just centimeters. Not centimeters squared, just centimeters. So to do one more example like that before we move into the packet a bit more, let's think about a rectangle that is 20 by 2, and let's once again do an area and a perimeter. Part of the reason there's a bunch of practice for these in the packet is so that you can practice them over and over to make sure you have them memorized, amongst other things. Let's say that this is feet, so I'll try to give you a unit every time we work on these. If there is no unit given, then it's just units, and you would still do square units if it is an area, and you would still just do units if it was a perimeter. So pause again, do your formulas, come out with your answers, and then play again. And as we resume playing, what we're going to do with area is we're going to take the length and the width, and we're going to multiply them together. 20 times 2 is 40, and you either have 40 feet squared or 40 square feet. And the perimeter, we're going to fill in our opposite sides. I like to add together those two and then those two and put them together. You could do it totally differently. It's up to however you want to do it. The one recommendation I will make when it comes to perimeters is make sure that you use a calculator to check your answer. Don't ever just throw them together and hope that you did it right, because it's really easy to make a mistake. So I'm going to do 20 and 20, which is 40. 2 and 2 is 4, so I'm going to get 44 feet. Sometimes your perimeter will be very similar to your area, and sometimes it will be very different, and it depends on the proportions. The closer it is to being a square, the closer they will be. So let's think about a backwards rectangle before we move into our irregular rectangles. So a backwards, it's not going to refer to an actual backwards rectangle. It's going to refer to them delivering you the problem backwards. So for example, they would say something like a rectangle. I'll zoom this in so you can see this better. So a rectangle has an area of 200 square units if this rectangle has a length of 20 units, what is the width of the rectangle? So these are backwards. They're not difficult by any means. They're just a little bit different. And again, pause the video and determine how you think you would solve this. Try to get your final answer and then play again. So as we play again, we know that length times width is how we would have gotten to area. So length times width gives us area. We're going to need to reverse that because we already have this, and what we're missing is one of the things that was over here. So what we're going to want to do is we're going to say that 20 times something. So we've got a length of 20 and 20 times something unknown. I'll put a question mark there for now. Gave us 200. And you don't need to involve the square part of it as long as you've got it parked in the area seat. You don't need to worry about actually writing it as being square. So basically the question is 20 times what would have given us 200? And the easiest way that we can solve for 20 times what gave us 200 is to take that 200, that final number, and reverse it by dividing. So if we had 20 times 10, then we would have gotten 200 for our width, for our area, making the width 10. Now you're answering in width, so you're going to do 10 units, not 10 square units. It all has to do with, is your answer one-dimensional or two? So if your answer is a length or a width by itself, or your answer is a perimeter, it's one-dimensional. If your answer is an area, that's the only time it's two. So to do another example of that, I'll just alter a couple of details. And again, you will see more practices, and you will want to practice as much as you can to become familiar enough with your equations or whatever you need to know in order to do these off the top of your head. That is the amount of practice that you would want. So let's say that I discover that I have an area of 20 square feet. And let's say that in that 20 feet, I have a width of, let's say 20. We'll make this a trick question. So a rectangle has an area of 20 square feet. If this rectangle has a width of 20 feet, what is the width, or the length, sorry, change that to length, of a rectangle? This seems like you shouldn't be able to solve it because the area number is the same as the width number. But keep in mind how this equation works. So you would have taken the width times the length, and that would have given you 20. If we once again just divide, we just reverse the process. The last thing we did was multiply, so the first thing we're now going to do is divide. Then we would find out that the length had been 1, because if you multiply, if you have a 20 there and a 1 there, that is a viable rectangle, and you'd just have one unit going in one direction while you had multiple units going in the other direction. The other way you can think of this equation, if it's a little better for you, is algebraically. So if you want to think of it as 20L, if you want to push that together when you go to do your solving and solve it like it's next to X, that might make the division look easier to you. But the way that I like to think of it is a bit more logical, which is just, what was the last thing we did? Let's reverse that. So if the last thing we did was multiply something by 20, then let's divide something by 20 and we'll find out what the something was. So as we move into our packet, there's lots and lots of practices for these. Each of them ask for one thing. They ask for an area, or they ask for perimeter. And I would strongly recommend doing both each time because it's better practice. So just add on perimeter or area, whatever's missing, do that for practice and add that on. The next thing that I want to look at together is the irregular rectangles. If you would like to practice more rectangles before we go on to this, you can pause and practice a little bit of the regular rectangles before you move on. Now, when we look at irregular rectangles, you can see right away why I'm calling them irregular, because they're not exactly a rectangle. And you would most closely relate it to if you had to name it based on a name you're already familiar with. So an irregular rectangle presents a few challenges, and I will go through a few of these. I recommend, if you struggle with these, because you might kind of replaying this little segment where I'm talking about the few that we do go through and following along maybe twice on the same problem to make sure you're in line. The first thing you'll notice on these irregulars is sometimes, usually, you have a missing side that's got no measurement. And the first thing you need to do is address those sides that don't have a measurement, because we need to have every single measurement. Again, this says that we're doing area only. We are going to do area and perimeter for each of these. It's better practice to do all of it and be prepared for everything. So when we do an area or perimeter, we need all of our sides filled in, because we might need those sides to put into the mathematical part of what we're doing. So if we look at this first one, there's really only one side that's missing, and that's that side right there. What you'll notice if you look at these, and some people adopt this concept immediately, others struggle with it a bit. If you are struggling with this a bit, kind of replay it, relook at it, and try to go through it a couple times to get the idea. There's only two directions that these lines are moving. They're moving horizontal. So here's all my horizontal ones in this particular rectangle, or they're moving vertically. And here's my verticals. That's the only two possibilities. So when you see a corner like this, some people get confused on corners because they're trying to act like it's a corner. And in reality, you should act like this is a vertical line and that's a horizontal line, and they're totally not related to each other. They're two different lengths. How we relate these will have to do with two things. So we need to figure out, is it going horizontal or is it going vertical? So these vertical ones that we've got in pink are not going to help us figure out our missing side whatsoever, because they're traveling in the wrong direction. So no vertical can help you figure out a horizontal. No horizontal can help you figure out a vertical. So how do we go about figuring out, once we establish that, what the length is? You'll notice something else, and I'm going to erase this and simplify the artwork a little bit. You will notice, let's just showcase the horizontal lines. So this is one of our horizontals that we're trying to find. Every time you have horizontals, and we'll move over to rectangle 2 as an example, you essentially have two concepts. You have a parent side, and the parent side is as long as either the length or the width, whichever it is, as long as it goes. There is nothing horizontal in number 1 that is longer than 8 centimeters. There is nothing longer than 8 centimeters. Everything is 8 centimeters or less. You can tell that because that reaches to the edges of the shape. So we have nothing that goes beyond 8 centimeters. That is the parent side. And what you'll notice is there's always one parent side for each. So if we look over here, we've got this younger side, this younger side. This is the parent side because nothing horizontally exceeds 10. The other two that are not the parent side, that are smaller, will have to add up to the parent side. They absolutely have to. So if you take this missing length and this length here, the two of those would line up. So if you excluded the vertical and you pushed this up here, they would be the same length as the parent side. That's always going to be the case, because if they weren't the same length as the parent side, you'd have a diagonal line jutting out from your rectangle. This is all contained ultimately, switch colors again, this all ultimately contains itself within a rectangle. So that means that whatever the parent side is has to be the longest side, and whatever the non-parent sides are have to sum up to the parent side. So if this is 5 and this is 8, I can take 8 minus 5 and find out how much I have left to be equivalent to the parent side. And the amount that I have left is 3. So that's how we want to find our missing side. We'll continue number 2 when we get to number 2. In this case, we're only missing that one side. We don't have any other sides missing. So now I'll erase all of my extra stuff to make it look more clear, as though that 3 centimeters was always there. Always check once again, make sure you're not missing any other sides. Now to do a perimeter, again, you just add all the sides. So now if you're thinking of perimeter as adding up all the sides, that's going to make it a lot easier on shapes like this that would be very confusing. I'm going to pick a place to start, and I'm going to pick a direction to go. So I usually start somewhere over on the left, and I circle where that is so I don't get confused. And then I go clockwise. So I'm going to add 3 plus, and then 8 plus, and then I come around here and it's 10, and I'm crossing these out so I don't repeat any, and then 5, and then 7, and then another 3, and that brings me back to my start point. I strongly recommend doing your addition a couple of times. It's obviously kind of easy to make a mistake here. So I'm going to add these all together, and this is 40, I think. I'm going to try it one more time. So 3 plus 8 plus 10 plus 5 plus 7 plus 3. Sorry, it's 36 because this looks like a 7, not a 3. So your perimeter should, in theory, be 36. And since I did make a mistake, I am going to check it one more time. So you have 3, you have 8, you have 10, you have 5, you have 7, and you have 3, making 36 centimeters as your perimeter. So when you do your perimeter, make sure you've got all your sides, pick a start point and make it very, very clear where you did start. Pick a direction to go around the start point and add until you get back to your original point. Do it a couple of times. It's really easy for the calculator to miskey something when you're adding that many things together. Now to do an area, here's what I recommend. Make your shape into 2 rectangles. Some people put a line over here and they make it into one big rectangle. I don't like that because I don't like the idea of then having to turn around and subtract. I've always felt like that was kind of bad. So instead, what I do is I use what I have here. I don't add something to it. I don't make it bigger than it already was. And I find myself a couple of rectangles. And it's pretty easy to do. I always go horizontal. You could go a combination of horizontal and vertical. So this very same one, I could have put the line here and made a little square over there and a rectangle here. Your ultimate goal is you put the line in somewhere that causes you to have 2 rectangles. And the logical reason why we do that is we're really good at doing the math for rectangles. So if we can just turn these into rectangles and get the area of each rectangle and then just add that together, add the 2 of them together, we'll get the entire thing with very little heartache compared to what we could be doing. So that's what I want. I want to find the area of the pink one. I want to find the area of the purple one. Here's the caution that I have to use here. I have to be very careful when I go to do this, not to use a side that crosses into both of them. I'll give you an example of one of those. 10 is part of both of those 2. If I use 10, I'll have an overlapping number and it will cause my answer to be too big to be accurate. So be very careful about that. Really outline what your rectangles look like I've done here, and be really, really careful. And then identify sides that only exist in the shape you're trying to do. So in this case, 7 and 5 are the 2 on the bottom. Up here, this 3 and this 8 are only part of the rectangle there. So we don't want to use a long side that's involved in 2 different rectangles because we'll have a repeat. Now all I need to do is multiply and find an area for each as though they were just their own little individual rectangles. So 7 times 5 is 35 square centimeters. And 8 times 3 is 24 square centimeters. Again, do your math a couple times just to be sure. So now we have 24 and we have 35, and all we need to do is add those together, and that will give us our area for the whole thing. So there's no more multiplying after that. You're just going to add them. So it's like if you measured up what the area is of the carpet that's in the closet, and then you measured up the area of the carpet in the bedroom. When you went to talk to the people about replacing it, you would just add those 2 numbers together, and that would be all the carpet that you need. So let's look at that again on 2. And we'll do 2 also together. So if you were live sitting here in class, I would just be continuing on. I haven't paused. After that, I will have you do number 3 and number 4 probably on your own. And then you can pause there. So let's look at 2 together. So again, I need to find any missing side I have. Now in this case, I have a missing side that's vertical, and I have another one that's horizontal. So I need to consider those separately. So the parent side, let's do the vertical one first. The parent side for the vertical is 7. No vertical line is longer than 7 centimeters. The one that I know about for the verticals is 5. So this vertical right here and this vertical right here, if you didn't have this in the way and you pulled this up here, they would add up to the 7. So 7 minus 5 tells me that I had 2 centimeters left, and I will label that right there. So my missing vertical line turns out to be 2 centimeters. If you get confused anywhere here, you can immediately back me up and look at it one more time. Here, I have 2 horizontals that add to 10. There is no horizontal line exceeding the length of 10. So 10 centimeters and 6 centimeters are the 2 that I know. And if I take them and subtract them, I will discover that this right here is 4 centimeters. FYI, they have to give you enough information to be able to actually find this. So you can only have one missing side of your horizontals and one of your verticals. And if you feel like you have multiple missing, then there's either something that's telling you 2 of them are exactly the same, to where you can just divide it in half once you find out what it is, or you're missing something, or you're trying to factor in a vertical with a horizontal, or vice versa. You're making a mistake somewhere. So now all I need to do is just figure out where I want to make my rectangles. I'm a big fan of always doing a horizontal breakup. It's totally up to you how you want to do it. If I do that, that's going to make that one there, and it's going to make this one down here. And now all I need to do is make sure I don't make any mistakes when I go to pick out which sides to multiply. So 2 and 6 multiplying together to make 12 are the 2 sides that don't cross over into anything else. When we look at my pink rectangle, 7 is the one that we don't want to use. That's in both of them. 5 is the one we do, and then 10. So sometimes you will have a parent side involved, and sometimes you'll even have 2 parent sides involved, but you've got to make sure it's not going into 2 areas. So I've got a 50 and I've got a 12, and that is an area of 62. Now I forgot to do perimeter. I always forget to do perimeter, so let's back up and do that. So to do my perimeter, all I need to do is I need to pick a place to start. I always start on the left. So it's going to be 7 plus 10 plus 5 plus 4 plus 2 plus 6. So the 7 is what I don't want to repeat. The 7 is what I've already got. So 7 plus 10 plus 5 plus 4 plus 2 plus 6 comes out to 34 centimeters, and our area came out to 62 square centimeters. Now you can pause the video to do 3 and 4. I'm going to run through the answers to 3 and 4 very quickly because I've still got several things to cover and not a ton of time to cover it all in. So I will go through those answers now. Pause me if you have not done those 2 problems. So the first thing that I would discover when I was looking at 3 is that I've got something missing here that's in my horizontals, and I've got something missing there that's in my verticals. Now the vertical that's missing is the parent side. That's the longest possible vertical side. So you're going to do your math oppositely. You're going to add the 5 and the 7, and that's how you're going to get this side over here. So 5 plus 7 will give you 12. Over here, it's not a parent side that's missing. The parent side is 30, and the side we know about is 20. Again, make sure you've established your lines and that you're going in the right direction. So that would make this 10 millimeters. To do a perimeter, I'm going to start over here. I'm going to say that I'm doing 12 plus 30 plus 5 plus 20 plus 7 plus 10. Going to be very careful with doing my math for that. So 12, 30, 5, 20, 7, and 10. I believe the perimeter is 84. If I'm totally wrong, that's a distinct possibility. And then what we're going to do is find a place to draw the line. Again, I'm not going to change my habit of doing it horizontally. If you have one that it totally doesn't seem to work the way you normally do it, you can always change just for that one instance. But it's always good to have a consistent way that you like to do them so you don't get confused. So now I've got my 2 rectangles. And again, I need to make the determination of which sides are most appropriate for each. 12 crosses into both of them. So I'm going to want to use 7 and 10 down here, and that makes 70. Up here, I'm going to want to use 30, and I'm going to want to use 5, and that's 150. So if we add up our 150 and our 70, we get 220 as our area. Moving right along to 4. If you have any questions or concerns there, stop, take a quick look, maybe replay it if you need to. Moving into 4, we have a missing side right here. And we have a missing side right here. And one of them is the parent vertical. The other is the parent horizontal. So the parent vertical is the sum of these two. And again, I'm going faster now, but as long as you're doing these practices, make sure to really showcase your sides and what they look like. 4 and 2 are going to sum up to make a 6. And then on the other one, we're going to have 7 and we're going to have 1. And that adds up to the parent of 8. So now I have all of my sides, and I'm going to get rid of all my extra lines and traces and circles so I don't get confused. And what I'm going to do is I'm going to start here, and I'm going to say 6, 7, 4. I need to be a little extra careful because I have a lot of sides on this one. So I have 6, 7, 4, 1, 2, and 8. That's coming out to 28. I will check it one more time. So I have 6 plus 7 plus 4 plus 1 plus 2 plus 8. And that is, in fact, 28. Now I can do my area. And again, what I'm going to do for that is I'm going to pick a place to make a line, and I'm going to watch out for what I need to use versus what I don't. Now, when I look at my bottom rectangle here, I need to use this 2 and this 8. Because the 1 is like, so the 1 we would only use if we made a little square over in that corner. So the 1 we don't use because of the direction we decided to go. So sometimes you will have extra sides that are irrelevant. Sometimes it's because they go into both of them, like the 6 on the left that I just crossed out. Sometimes it's not because of that. It's just because it's excess and it's not going to do us any good with the shapes that we picked. So that leaves me with 8 and 2 down here, and that will give me 16 square meters for that bottom area. Up here, I'm going to have the 7, because that is the parent side that goes with this. And I'm going to have this 4, which will make 28 square meters. Now all I need to do is put together my 28 and my 16, and that will give me an area of 44 square meters. That is more of the practice runs on this than I do in the normal class. I usually only do 3 of them. So it's a little bit of extra practice. Like I said, replay if you have any confusion there. Irregular rectangles is at least the number 1 or maybe number 2 challenge in the class. You'll continue to see more and more of those practices as you go along. So make sure that you are comfortable with that so that you can get those right if you do see them. The next thing we want to look at is circles. So we have circles, half circles, and then certain types of triangles to look at. So we're about halfway through, although the second half is a little bit harder than the first. So when we think about circles, now we're thinking about an area that we actually do have to have an equation. So we can't just kind of look at a circle and see what we need, because you may remember that circles use a factor that rounds them, that shapes them the way that they're shaped, and that is pi. Pi is 3.14. Your exam will always tell you to use 3.14 as pi. You'll never use the pi button. Double check me on that. Don't just assume it's going to say that, but I've always seen the test say use 3.14 as pi. So with an area or a circumference, we are going to have pi, because obviously we have edges that are rounded, so we can't just measure an edge. We need to measure through the center using one of 2 possible figures, and then we need to use the 3.14 to create the circular spread. Now, when you learned these, and I'm going to write these in red because I don't want you to write these. I just want you to pay attention to what I'm saying about them. These are not the equations you're going to use. The equations you have probably learned for these 2 things. You probably learned that pi r squared was the formula for area. Don't write these down. And you probably learned that 2 pi r was the formula for circumference. Circumference is the perimeter, by the way, of, you can write this down, perimeter of a circle. So it's got its own name. Well, you might be able to already tell the problem with this. The problem with this is I have an r, a 2, and a pi sign in both of them. How in the world are you going to remember which one's which? And that's what I've always wondered with every high school kid I've ever tutored, everybody who's ever been learning geometry from a practical, educational institution, is I'm like, why do they teach it this way? Because how in the world are you supposed to know which one's which? Here's my recommendation. We're only going to use the r and the 2 when we're doing an area. So I'm going to erase this. I'm going to make a stylistic change. I'm going to put the r squared that we just had. I'm going to put pi on the right, not the left. So instead of pi r squared, it's r squared pi. I'll tell you why I'm doing that in a moment. That is your real and true formula for area. Now with the circumference, we're not going to use 2 pi r. Another way of saying 2 pi r, if you eliminate pi for a second, is 2r. Now the radius, r, is the distance halfway across a circle. So when we do an area of a circle, we identify the radius, which is halfway across the circle. So what we can do is, instead of using the radius for a circumference and multiplying that radius by 2, because that's what this equation is asking you to do, is multiply the radius by 2. Instead of doing that, we can just use the diameter. The diameter is the distance all the way across. I'll make a bigger visual over here of this. So the radius is the distance halfway across. The diameter is the distance all the way across. If you took the radius and you multiplied it by 2, you would get the diameter. And if you took the diameter and you cut it in half, divided it by 2, you would get the radius. So no matter which piece of info they give you, you can switch seamlessly back and forth between the 2 of them more easily than any other equation that you're dealing with. So instead of doing 2 pi r, I'm going to do diameter instead of radius. So now I don't have r in both spots. And I'm going to put the pi again at the end. So instead of pi r squared and 2 pi r, we're going to do radius squared pi and diameter pi. Remember that anything written together like that is being multiplied. So r squared pi, you're taking the radius times itself, and you're multiplying it by the pi sign, the 3.14. Circumference, you're doing the diameter, which is the distance across, and you're multiplying that by 3.14. Now, the reason that I tossed the pi sign on the far right is because you're not always going to actually multiply that when you're on the TEAS test. So there's going to be instances on the TEAS where instead of having you actually finish that out and multiply it, you'll notice that your answer actually has the pi sign still in it. So they kept pi in the answer. So let's put these on here so we've got them for reference. One of the most important things to establish and get good at here is make sure you know which one's radius and you know which one's diameter and you know which one matches better with which equation. You can use a radius or a diameter for either one because you can easily switch from a radius to a diameter or vice versa. But know that when you see a radius, you're already set up for an area. And when you see a diameter, you're already set up for a circumference. If you're trying to do a circumference and it's not a diameter that you have, that should throw up a red flag that you need to switch something around, and vice versa if you're doing an area and you have a diameter. Now, again, with the practices, you'll notice that they just ask you to do one thing, and I strongly don't recommend doing one thing because I think it's best to practice both of them every time. That prevents you from getting used to one of them and accidentally always doing that one because that's what you always practiced, i.e. doing a circumference when the test asked you to do an area. And it also prevents you from losing out on any possible practice. So do every possible equation for every one of these things while you are practicing. So this one is going to ask you to do an area. I'm going to ask you to do an area and a circumference. So let's look at A, which is the first question. And the first thing we need to establish is, do we have a diameter or a radius? Diameter is the distance all the way across. That is what they are showing us here. And the distance across is 16 centimeters. So if I am going to do an area and a circumference, I can kind of do myself a favor by starting with the thing that uses the right piece of info for what they gave. So since they gave me a diameter, why don't I start with circumference rather than area and then go and cut it in half when I do the area? So the circumference is diameter pi. The diameter is 16. So you're basically done in about 3 seconds after you put the 16 in front of the pi. Now, there are two ways that you might see this answer expressed. And you need, when you get to right here, you need to stop and check your answer choices to see which expression they are in. So if the answer choices have a pi sign in them, then you're obviously done. You can just put 16 pi and move on. If not, if you see decimal answers, then you need to go ahead and multiply the 3.14, if that's what the question tells you to use for pi, and get the actual and true answer. There's an in-between to that as well as an additional FYI. Occasionally, they will actually say in the question, they'll say, what is the circumference of the circle below in terms of pi? What is the area or the circumference of this in terms of pi? That would cause them to have even answers that would be consistent with what you would see next to a pi sign like this. But since they mentioned in the question that they were in terms of pi, you won't actually see the sign there. So it's a red flag that that happened. If you look at your answer choices and there's no pi sign, but all the answers are perfectly even, think about how few instances you can multiply something by 3.14 and come out with a perfectly even answer. That would be very rare for that to work. So if they're all even like that, go look at your question, and I bet it said that all the answers were in terms of pi automatically, and it's assumed. So those are the three possibilities. You'll either see a pi sign in the answer, and you know you can just leave it there. That's why I put it at the end. That's why I always have it on the far right, so you don't have to shuffle anything if that happens. And then if you don't see any pi sign, but the numbers are perfectly even, double check the question, but most likely what you're going to do is just leave the pi in place and just cut it off of there. And then if you see decimal numbers, that's a dead giveaway that they did do the final multiplication. Let's do the same process on the same question, but let's do the area. When we do an area, we only want the radius. We only want half the distance across. So the area is going to be based on radius. And if the diameter is 16, half of 16 or dividing by 2 is 8. So we're going to use 8. Now, the formula for an area is the radius squared times pi. Very important to remember. Squared does not mean times 2. It's not even involved in the 2 hardly. It's the number times itself. So this is asking us to take 8 times 8, then multiply by pi. 8 times 8 is 64. So if the pi sign remains in my answer will be 64 pi. If it doesn't, then I will take 64. I will use their suggested equivalent to pi, which is probably 3.14. I will multiply, and the area will turn out to be 200.96. Let's look at B, and then we will move to half circles. I recommend practicing lots of circles before you actually move on to half circles. So using the guidance I give you on these two, practice at least 5 or 6 of these. Be very comfortable with them before you do half circles. So on B, again, we're going to do an area and a circumference. And this time I'm going to start with my area because I have a radius. The given piece of info I have is the radius. So 9 is my radius. And if I take 9 squared and then multiply it by pi, I will get the area. 9 times 9 is 81. So my area is 81 pi. Or if pi is not remaining in the answer, 81 times 3.14 is 254.34. So 81 pi or 254.34. Now to go on to my circumference, which is my distance around, I'm going to want the diameter. So if the radius is 9, then the diameter is 18, which is twice the radius. So my simple answer is just 18 pi. So the one up here is 81 pi, and then circumference is 18 pi. If they did happen to go ahead and multiply, we would have 18 times 3.14, and that would give us 56.52. So 18 pi and 56.52. Go ahead and practice more off of this sheet or anywhere else you find regular circles in the packet before trying to move on to half circles. Now, again, you are fully responsible for knowing your equation. On rectangles and irregular rectangles, you don't have to go crazy with memorizing an equation, but you do have to know them. And same with circles, except circles you really do kind of have to memorize. They will not give you a formula for any of that. All they'll tell you is to use 3.14 for pi. Segment is half circles, and these are really challenging to a lot of people. So once again, I'll do a couple of examples, but I strongly recommend replaying them if you are confused and making sure. We really want to be conceptual here. We really want to understand why we're doing the math the way we're doing it. So don't try to memorize how we do a half circle. It's okay to memorize the formulas for regular circles because there's not much else we can do. Don't try to memorize how to do a half circle. If you don't understand the why, you won't understand how to take the question, figure out which route to go with it, because there's 2 possible routes, and execute that correctly. These 2 questions, and I flipped a couple of pages ahead. So this is page 5 of 9 is what it says. This one says, what is the area contained in this shape? This says the distance around this shape. So these are the 2 possible types of questions for a half circle. So skip to here so that we can see them side by side. So if they give you a half circle, then there's one of 2 possibilities as to how you will execute it. If it asks you for the area, remember what an area is. Remember that the area of something is the space inside of it. If they ask you for a distance around something, the distance around something is all of its external sides added up. So if you are asked for an area of a half circle, all you're going to do is you're going to do the area and you're going to divide by 2. And that's all you're going to do. Why? Because if I had, and I'm going to kind of do this in 2 halves like this. So if I had a circle like this and I had its area filled in and I cut that circle in half, so I just chop it right there. It's the same exact thing. It wasn't impacted by the fact I cut it in half, except that it got cut in half. So you'll just take what your normal area would be, you'll chop off half of it, and you'll have your half circle area. Distance around does not work that way, and here's why. If I wanted the distance around a circle, it would look like that. So the purple line, which is the circle, is the distance around the circle. So you'd start here, you'd walk around, you'd end up back here, and the circumference would be the measure of the entire length of that curved line. When they cut it in half, they don't just cut it in half. So if I cut this in half, what I would end up with would look like this. So I originally had a circle like this. Circumference was the whole thing. I cut it in half. I get this. When I cut my area in half, I literally just got the same thing that I'm looking for just by cutting it in half. You'll notice here, what is the fundamental difference between that drawing and that drawing? Take a moment to look at that. Pause if you want to. There is a fundamental difference in what is shown in this picture versus this one. That fundamental difference did not exist on area. So area, it truly, you just cut it in half. The difference is this right here. When they cut this in half, they put a line connecting one half of the arc to the other. That was not there to begin with, and that was not part of my original circumference. An original circumference looks like that. If we cut it in half, it does this. And then I have to add that, and that's different. That's adding something additional. So this shape right here, and you notice they call it this shape. This is not half a circle. That is a half circle plus a line. Now you may be saying, well, so is the top one, right? True. The top one is also a half circle plus a line. But when we're doing a circumference, the lines that go around the outside matter. They are part of the distance around something. When you're doing an area, it doesn't matter that there's an additional line because the line is not in our answer. The space is in our answer. So cutting a circle in half would cut the area in half whether or not you added another line to it. That's a technicality that we don't care about. When we do that on a half circle that wants a circumference, we're actually adding a whole nother side that isn't normally there. So when you do an area of a half circle, you just do the area, you get the math done, you divide it in half. When you do the distance around a half circle, you do the circumference, you do the distance around, you divide it in half, and that will give you that right there. So then after you do that, then you have to add that line, and that line will be the same number as a diameter. So it's the same diameter that you'll use to do your half circumference, but you've got to add it on because it's a physical line that's added to the circle that wasn't there before, and that's not part of a circumference formula, because a circumference formula will give you that, and then if you cut it in half, it'll give you that. So then you're going to have to add this flat line, and that's going to be equivalent to what you said your diameter was. So let's do the area equation up here. What is the area contained in this shape? And they gave us r equals 9, so that's radius. You have to be extra careful if they don't draw it on, because sometimes they don't draw on the radius or diameter, and you can accidentally picture it wrong. So a radius is halfway across. That is what I want for my area. So if I take 9 and I square it, I'm going to get 81 times pi. You can divide by 2 before you do the pi multiplication. So 81 divided by 2 is 40.5, and I still have pi there. So 40.5 pi. I could answer that with pi in it, potentially. Depends on the format of the answers. Or, once again, I could take that and actually multiply it by pi, and that would give me 127.17. Now, with the circumference, it's a little bit different. So, first of all, this is a radius, and we need a diameter. So, we need to multiply that radius by 2, and that gives us 14. So the regular original circumference formula would be 14 pi. So 14 pi can be divided in half. Again, before you actually apply the pi, it'll be a lot easier to do it that way. And that will give us 7 pi. Then I need to add the diameter. And we know what the diameter is because we've used it. It's 14. You cannot add 14 to 7 pi. They're not in the same format. Pi represents a multiplication. If you added the 14 and you just said 7 plus 14 and then the pi sign, you'd be multiplying the 14 by pi as well, and you don't want to do that. So in this one, you have to do pi first. So you have to do the pi first. So 7 times 3.14 is 21.98. Now I have a normal number. Now I can add my other normal number, which is 14, to get my sum, and my sum is 35.98. So it's a little bit different of a process. Again, don't try to memorize this. I explained it all ahead of time before we started looking at numbers so that you can really visualize and understand it. But you need to come from a place of looking at the shape and deciding, is this just half of what I'd normally get, or does it have something extra on it, something taken off of it, or whatever the case may be. So you've got to be careful to be very practical, look at your shape, and figure out if you're using the extra side or not. The extra side is added to both of these, but the extra side doesn't impact area. So if you yank one of your walls completely off of the room that you're currently sitting in, the carpet will be the same size. It's not going to affect the size of the carpet. If you rip one of the walls off and you're trying to measure the distance around the wall, well, yeah, you just totally changed what the measurement is. Similarly to if you add a wall in the middle of the room. Now you have more distance that you have to factor in. So practice those half circles, lots and lots. They do get a little tricky. We have one more concept to look at. Most people think this is actually quite a bit easier than the other concepts. So this is something, again, you've probably learned at some point, called the Pythagorean theorem. You can label this up at the top if you want to. Pythagorean theorem. Pythagorean theorem is a rule that applies only to right triangles. And as a reminder, a right triangle has this right angle in the corner. And it is obviously a triangle, has 3 sides and has a right angle. There's a couple of properties to remind yourself of in regards to right triangles. So this is a side, and this is a side, and this is something called a hypotenuse. And when I'm saying this, I mean the diagonal. Now, sometimes which side is actually the diagonal is difficult to identify. Sometimes it's very obvious which one's diagonal. Sometimes it isn't. Here's a tip that they may have never told you. The hypotenuse is always directly across in a straight line from the actual right angle. So it's centered to the right angle. So the hypotenuse has to be that particular side. It's not interchangeable. The sides could be either of them. So these are both called side, and they're interchangeable in every way. The hypotenuse is unique. Here's the thing that has to be true about the hypotenuse. So it has to be the diagonal. It has to be the longest side. So if you ever do your math and you discover in the midst of your math that your hypotenuse is shorter than something else, that is impossible. You've mixed something up. And it has to be directly across from the right angle. So those are the qualities that you need in your hypotenuse. So the first step you're going to have to take is determining which thing is which for the question that you'll be answering. Now, first, I'm just going to show you what Pythagorean theorem is, and we're going to solve this using it. Then I'm going to show you what they would actually ask. So if they gave you this and you could see this and you had full control over this picture, I'm going to erase everything. You would see that one of the sides is 20. The other side is unknown, and the hypotenuse is 25. The equation that applies to any right triangle says a squared plus b squared equals c squared. And a squared is going to be a side squared. And then c squared is the hypotenuse squared. So the side is A, the side is B. It doesn't matter which one's which. They're not the same. So I'm not saying that the two sides are always the same as one another. I'm just saying that it doesn't matter where you put them in the equation, because when we add two things together, it doesn't matter if we do 1 plus 2 or 2 plus 1, you're going to get the same thing. The hypotenuse has to be over here. So the hypotenuse is the diagonal side, and it's going to be different. So what this says is if we take the side that we know the measurement of, and we add that to what we'll call x squared for now, or b squared if you want, and we square both of those, and we add them together, and then we also square our hypotenuse of 25, that when we add these two on the left up, we will get this one on the right. So the two sides added together after being squared will be the same distance as the hypotenuse when it's squared. So the first thing we need to do is we need to square the numbers, and it's really easy to forget that. So 400 squared and 625. Sorry, I said 400 squared. What I mean is 400. So 400, and then x squared we still can't do anything with because we can't square an actual letter. We can't find out what the squared version of a letter is. So we've got 400 plus x squared equals 625. Now you're going to switch to algebra. And all you're going to do is isolate that letter that we don't have. That's just like an algebraic equation. We just get rid of that. And that tells us that x squared equals 225. The part that's a little bit different about this, and most of my students have done this at some point, and this is kind of coming back to you, is you have x squared equals 225. Well, x squared being 225 does not mean that x is 225. So what we have to do to reverse this is we have to do the opposite of squaring. We need to know what x is, but right now x is squared. The opposite of squaring is a square root. Your calculator has a button that looks something like this. It says like SQR, square root, or something like that. Doesn't have the little symbol. So if you don't see the little square root symbol that looks like that, it's like SQR. And what you would do is you would hit 225 and then hit this button, and it would square root the number for you. And the square root of that number is 15. So that means that if we apply Pythagorean theorem, we find out that that side over there is 15. So we have 15, 20, and 25, which does leave the hypotenuse as the longest side. So that is how to do Pythagorean theorem. Again, I would recommend practicing a few of these. Put me on pause while you do that, and then coming back to this final explanation. So the final thing I want to talk about is the slightly different way you're going to see this on the test. And if you're not being careful and logical combined, you might think it's something you don't know how to do. So what they'll say is they'll say the hypotenuse of a particular right triangle is, and let's say it's 5. And it'll just ask you, what are its sides? Knowing that a hypotenuse is 5 does not tell us what the sides of it are and whatever number they give you. They might not give you a 5. They might give you something totally different. We do not know what the sides of this are just glancing at it. That throws off most people to where they feel like they don't know something they're supposed to know, or they're missing something and they don't know how to do it. Keep in mind, you have 4 possible answer choices. What they're really asking you is, what is the what is a possible combination of sides? What is the answer choice that's actually a possible combination of sides? Because they have to satisfy a squared plus b squared equals c squared. And if they don't, then they can't be the sides that go with this. So what you're going to do is you're going to put 5 over here squared, and you're going to put in the 2 things that they list in the answer choice. So let's say, and I'll do the correct answer. So let's say that you have an answer that says 3 and 4 are the sides. So you put 3 squared in here, you put 4 squared in here, and only once of all your 4 answer choices, only once will you actually do the math, 9, 16, and 25, and actually discover that they make the equation true. If you put any other 2 numbers in there, it would come out to being like 20 equals 25 or 35 equals 25. Obviously, 20 or 35 does not equal 25. So you'll only have one possible combination of sides that when you plug them into the equation, square them, and add them together, actually end up making the statement true. And that is a possible combination of sides for that particular triangle, not the sides. So they will word it as though you're supposed to just magically know what the sides are. That's not what they mean. What they mean is which of the answer choices makes the equation work. So that is a jam-packed geometry class. Again, pause anywhere you can to work on some of this and keep along with the class the same way we would do it if we were live. All of you have been in class live. And then let me know where you have questions or issues. Repeat anything you need to repeat and practice with more numbers. And then when you're totally done with this packet, you can let me know so that I can send you the keys. So this is all of geometry. Normally part of this is in the advanced math class, but you have now everything that is geometry. That is it. I will see you guys later. Thanks.